Couple of points. First point is, again, people are wondering, John is wondering why I'm, where is John gone? Why I'm always so opposed to the standard committee. It's not just the standard committee, it's much broader than that. I am opposed to self-appointed experts, right? That is, for several hundred years, basically from the beginning of 17th century, we have this formation of scientific community, which developed certain ways to assure that what we have is reliable. It's those of you who remember my earlier lectures might remember Father Michel Mersenne. Mersenne, what was his first name? He was not Michel. Father
I don't remember.
Father Mersenne, who was sort of collecting letters from different people, people like Fermat, people like Pascal, and sending them to each other, creating scientific discourse. Then, within few decades, people started forming scientific societies and refereed journals, right? And this mechanism for sort of creating science is the mechanism which we got. Is it a good mechanism? No, as most human mechanisms, quite flawed, right? It's like democracy, right? Which is a terrible, terrible system, as Churchill said, except for the alternatives. So the same thing with the scientific community. It's a community which exists somehow. Of course, there are careerists, there are people who are not really concerned about the truth, but it functions. It served us very well. You know, bridges do not collapse, planes fly, television shows images, right? Sort of in universities, we know how awful universities are. You know, junior universities or some other universities, but they still, if you want to learn, if Ryan comes to me and say, oh, I want to learn, I have to say, Ryan, go back to school. And I mean a university. In his case, junior university across the road would be a good place. But they are these places. Sadly enough, what has been happening, and that what I find disturbing, is that instead of this community, scientific community, which self-regulates, which sort of expels charlatans if they cross certain boundaries, came about this self-appointed community, especially in computer science, right? So we're becoming like, what is the people who study extraterrestrial? I mean, we're becoming like the science fiction convention. People could go, anybody could go. And that frightens me. I think it's a very dangerous direction, right? Sort of where people with no qualifications could suddenly become great experts. They never went through any process of publication, of tenure committee, and say, but tenure committees are not good. Yeah, they are not good, but so much better than no committee, right? So I'm trying to defend, I mean, you know, the existing scientific community, broader than computer science, as something which is fundamentally good. And any attempt to bypass it, again, I have arguments with John. Sort of when he says, oh, we're doing our own conference, I shudder. Because it's not part of an established community, right? There are some people who go there and they say, we're great people. And if you pay, whatever you charge, $1,000, you know, you could hear our wisdom. That is a very, very dangerous path. And this, yes?
Isn't that how scientific
No, no.
And you have people who are part of the community. Who
No,
produce things
no,
for the community
no.
and
That's
they-
how science fiction communities are formed. No, scientific
So what's the
communities, restriction, university. Go to university. If you want, you have to go through this harsh barrier of a modern university system. Yes?
I published a paper personally before I graduated from university.
You're a brilliant man, you might be next Einstein. But I am not talking about you. Okay? I'm sending a message to say, Ryan, if he wants to study, he should go to Stanford. Not necessarily. Could be MIT, CMU, Urbana-Champaign, University of Texas, Austin. Do I have to go through the list? There are many of them, right? These are places which dedicated to teaching, right? And yes, the human beings work there. And some of them, and you know, might teach computer science and not really be great computer scientists. Much more likely, they are great computer scientists than people who never been to these places, right? This is why, again, what I'm telling you guys, go read Knuth. Why? Because Knuth wasn't one of these places he universally recognized to be, again, used, I mean, however, when somebody says, but from my point of view, Scott Myers is much more useful. Sorry. I mean, I do not think so. There is a reason why people at Stanford do not use him as a text for graduate courses. I think, do they, Anil? Yeah. No. They might now, yes. But there is, I mean, okay, so I am just saying that, you know, these things are good. So it's not an attack on some particular individuals, an attack on trying to bypass existing academic establishment as a way of going. If you want to publish, go to, yes.
So I'm somewhat confused because my experience with academic conferences and the scientific community is it's very much a meritocracy where you, regardless of your training, you can go there and submit something, and if they recognize that it has value, then you're allowed to speak.
No, it doesn't work like that. But it's not a meritocracy. You have to be known. Your theme should be viewed as fashionable theme. It's a very, very different from whatever you just said. It's a very...
I did it. So, I mean...
So did I.
How...
We could look at how many I published versus how many you published. I might have published more.
It's entirely possible, but I mean, that's irrelevant. One example is enough, right?
No.
It's enough to suggest that the system can work the way it worked in that example.
Well, I do not know. What I'm trying to say that in my case, the fact that I published papers in refereed journals does not prove a thing. But nevertheless, that's the path of going. In your case, maybe your paper is brilliant and proves something. In my case...
No, it doesn't prove anything. It got published in a refereed journal. But it didn't require that I have a graduate degree or that I...
No, it does not require, but I think it would do much good if you did. You know, I'm talking quite honestly. If you want to learn, go.
Well, I did go to university.
Go and get a graduate degree. Okay? Would do you good. Will teach you some humility for one. Right? Look at Anil. Okay? He keeps his mouth shut. Why? Because he had this advisor who was pretty smart, and then he had another advisor who was pretty smart. And then he had managed to have 3 advisors who were oh so very smart. 2 of them won Turing Award, and 1 of them could do card tricks better than anybody in the world. Am I correct? Right? But therefore, he knows that it's hard. Right? when he talks, there is certain, again, I have to say humility, which I think you need to acquire. And I think going to a top graduate school, I have a friend, many of you know him, Mark Ruson. May I finish the story? May I finish the story? Okay, you know Mark Ruson. He was a valedictorian at University of Southern California, got admitted to Stanford Computer Science Department, and he says that for the first year, he felt that he was the dumbest guy in the entire graduate school. And you could ask Anil, he probably felt like that. You know, it's really good to go there because there are just so many people so much smarter than you. And they put certain good aside, because we all know when we're at home, our parents say, oh, you're the brightest kid. Then we might be even lucky. We go to kindergarten and we are very bright, or our teachers say, he is very bright but lazy. You know that. But then the real life comes when you go to, say, Stanford Graduate School, meaning, well, you're not bright. No, if you're lazy, you don't get there. So, and I think it's very good. And I think it's very good for all of us to get this. I mean, you know, I was very fortunate when I started my career. You know, I met people like Kolmogorov, and I knew that, I don't know, that I was this little ant. Because, you know, and will remain however hard I try. And what I see in the self-appointed organizations, or people who go to these places, I see this attitude, but I'm brilliant. No, you're not. Newton was brilliant, yes. Euler was brilliant. None of us are brilliant. I'm not saying I'm brilliant, you're not. I'm saying that, you know, I have been working very hard trying to study for very many years, and what I have discovered is that I'm an idiot. That very simple things like equality, takes me decades to make little progress, right? And I think it would be very good for all of you, even you, Ahmed, to get this attitude that you're actually not that bright. I'm not saying I'm brighter. I'm just saying that very few people at a 9 are at the level of Euler. Those who are, raise your hands. Amen. He's dead, okay. But it's good to measure yourself against Euler. Do not measure yourself against, you know, if Param and I start measuring against each other, it's pointless, right? And you will make much more progress. You'll get much better things if you start with this attitude. And if you respect sort of the traditional scientific disciplines. This is why, I mean, you heard me time and time again, study mathematics. Have you heard me saying study mathematics? Oh, okay. But, you know, it's precisely, again, sort of mathematics is this thing which, again, puts, I don't know, sorry to say you don't know things like that, but it puts fear of God into you. Because you just look and you say, this is this grandiose thing, and I can never, however hard I try, will comprehend it. And it's good. It's literally a very liberating experience, guys. Realizing what we are, how insignificant we are, is a wonderful, liberating experience. You cannot fly. It's very liberating. You wouldn't try, right? So, again, what did you want to say?
I was just curious about whether you've actually been to conferences where people actually pretend to be, like the conferences that John and I go to, like the one that we went to last week, which you seemed to be insulting.
No, I'm not insulting. I'm saying it's not an academic conference. Is it? No. Okay.
But the level of discourse there, or you seem to be suggesting that people who go there and present there think that they're the best things in sliced bread.
Or some of them for sure.
That's not the
I know them. I know them. I have known them for many more years than you.
That's not the attitude of the people that I see presenting.
Alexandrescu was not there?
No.
Sutter was not there?
No.
Oh. So it was all the usual suspects. What's his name? The greatest person. The efficient C++. Scott Myers. That was it.
He wasn't there. The people who I saw there were very open to feedback, and they promoted discussions with the audience.
Why don't you guys then attempt to start a SIG plan sponsored conference?
Why do we need like?
Okay, that's something which apparently you do not get. Affiliation with an academic establishment makes you part of the community. You say that you don't need them, fine, but then don't ask me to respect you. Okay? I do respect people who go to Fox. Do you know what Fox is? Or you've been to conferences, I hear. It's probably the most famous conference in computer science, symposium, fundamental of computer science. Stock? No? No? You haven't been there? All right. So when you learn at least the names, Symposium on Theory of Computer Science, yeah? Of computing. When you learn the names of these conferences, then let us talk. Right now, you disregarding what exists.
No, I'm trying to understand the distinction. You're saying that I'm displaying hubris when all I'm asking is for you to explain the difference.
The difference is that there is this community formed many years ago called axiom. Right? Is it a perfect community? No, it's a dreadful community. It's the best we got. Right? And I think that we have to follow them. We have to attend their conferences. We have to go to, however much you might dislike SIG plan. It's an academic conference with honest, associate professors reviewing papers and, trying to do, yes?
So, I would kind of like to move on, but I will say in defense of our little conference, it is held in cooperation with the ACM.
This is good.
We have that connection. I will also say that the only question they seemed to be concerned about when they applied for connection was how diverse our program committee was. They never once asked a question about any content. So I think that's part of where the frustration comes from. But I don't really want to get into it. I'd rather move on.
Again, in any case, I'm defending, and it's not a right place. I would be much more popular if I was saying that at Stanford and here. Practical programmers right now tend to disregard academic computer science, and I think it is a terrible mistake. So that's the only thing I'm saying, right? I think these people deserve our respect. I think that you should try to buy books written by people who won Turing Awards, whomever they might be, and study them. I think it would do you good, okay? It doesn't matter to me, by the way. I didn't win Turing Award. And I never tell you to buy my books. I give them away, as you well know. So, okay, let's go to equality. This is, okay. Let us forget programming for just a few minutes. We need to figure out how we deal with equality when we talk about things. Right? Because after all, whatever we program comes from the real world. Yes? Sort of we somehow map reality into these bits. And when we look at the reality, we have this thing, which, by the way, sort of a difficult thing. We have a notion of a part. What do we mean by a part? Is my wife my part? Some people in some peculiar countries believe so. But I clearly know that my wife doesn't. Is she right or not? Is there a test?
If we destroy you, your wife remains.
Yes. Yes? If I die, again, there were countries once upon a time. Let's not mention them. Sati did exist, but in any case, we clearly know, and here we come to this very important sense of what a part is. A part is something which disappears when the object, here I'm not talking about computer object, real object, disappears. And people could say, well, but you break a chair, but the leg remains. No, in some fundamental sense, it's no longer a leg of a chair, it's just something. It's just a piece. So this is the idea which we want to sort of capture. Another thing that when we talk about equality, one of the, you see, we cannot really implement Leibniz axiom. You cannot go and test all the predicates on two things, way too many. But we could come with a sort of simple rule which will tell us how we could compare two things by equality. And the rule would sound, I'm talking about things in the world, is that two things are equal if they have the same form and equal parts. So they have the same shape. Shape is something which shows you how parts are connected together. And then so, if I iterate along the form and look for equality of parts, I will get equality of whole. It gives us some idea. And again, somebody might say, well, there are exceptions, and it's not a bad thing. And we go through parts, we do not compare, for example, when we compare two people, whether they're equal or not, we might look at their parts, we might even include some attributes which are not really parts, like a salary, but it depends what kind of equality we're talking about. But we really do not want to include wives. We do not want to go and look at equality on wives. Yes? So this idea that we could sort of separate the world, at least mentally, into these things which come together, destroyed as a whole, and have this, gives us a certain kind of semantics. Am I trying to describe real world? No. I'm trying to describe a limited and fairly conventional model of how people view it. But it works. I think many normal people who know nothing about computer science will recognize, will somehow relate to what I'm talking about. At that point, Dijkstra, if he were alive, would jump and say, well, we don't want any anthropomorphic reasoning. Well, I actually say it's perfectly good to use some anthropomorphic reasoning because guess what? That's the only reasoning we got. So we could take the way we sort of look at the world, we have this notion of part, which is a difficult notion. But we could say, well, we somehow lift it, and we could build our universe in the computer, things like pairs and vectors, using this idea, the notion of part, the notion of equality being same form. By the way, what does it mean, same form, say, for a vector? Number of elements, it's a linear structure. For a tree, that's harder, right? Because for a tree, and let's assume that we use ordered trees, we have to look at sort of tree equality, the same shape, sort of as we traverse. Everybody has the same number of children, and all the children are correspondingly equal. Right? So it would work. For those of you who are interested, the algorithm is in Elements of Programming, the book freely given to members of this course, which of course no member of this course will ever read. But that's against the rules. Too academic. This what we're trying to do here. We will try sort of, I don't want to go through the code, Param will do a much better job there, but I just want to give you the intuition. We're trying to build the universe of these things where things have parts. If you destroy things, all the parts are destroyed. When you copy things, you copy all the parts, and you create the thing of the same form. You sort of, I'm sure all of you sort of see what it entails. Again, things are disjoint. Parameter cannot share a leg. By the way, why not? Prove it. Yes, and if you kill param, I don't want to lose a leg, right? Sort of, because we say that if you kill param, all his parts disappear, I lose a leg, and that wouldn't be fair. So we have this disjoint.
I lose a life, you just lose a leg. It's okay.
Yes.
Weak reference.
Weak reference. Yes. Again, yes, you could use copy and write to assure that he keeps his leg and all other things. But it's not, I'm talking about overall semantics, not about the implementation details, right? Sort of, I think the notion of part is a powerful notion and could be used very well to incorporate all kind of data structures into the programming universe. And Param will lead it.
So this is going to be anticlimactic, but we need to implement less than. So let's get on with less than. Does someone want to dictate?
Shall we use lexicographic order?
Oh, first, okay, what should it be? Anil suggests we should use lexicographic ordering. I think that's a very reasonable suggestion. So tell me what to type.
Template.
Copy.
Order. But yeah, let's.
We talked about less than. So what if something has less than defined? What is it? What must it be? What kind of thing?
Well, no, the ordering we talked about.
Yes.
Strict weak ordering.
Yeah, let us look. I think the board is very good. So let's look at the meaning of this. This thing. Yes? Okay. What's the negation of this? Tell me what's the negation of it. Do you agree? Yeah, any programmer who knows no mathematics knows that. Right? Now, if we have two things such that A and what do we know about it? You agree, yes? What kind of ordering do we have? What kind of ordering is this ordering?
He just answered.
Total ordering. It is total ordering. It's not a weak ordering. It's total ordering. Why? Because the equivalence is equality.
So we're going to require that of our less than.
If you have less than, you have to require that less than is less than. That's what we're requiring. Because we're going to use this. What are you guys doing?
I'm implementing less than.
Oh, I see.
Okay, so now what goes here?
That's very tricky.
It is tricky. Yes.
Just tricky. So think.
X is less than Y.
No, X
Or
first.
X is
X
both equal
first.
to
X
Y.
first.
X first is,
Less than Y first.
okay, let's get it Y first.
Or they're equal and second.
No, you have to know they're equal second. Because first you want
It really depends on the way you're going to measure.
Okay.
I mean, we
first
said we
of all,
wanted
guys,
lexicographic ordering. What does that
calm-
mean? For
Calm
a pair?
down. Let us use an axiom. Which axiom have we got? Useful axiom. I claim trichotomy. Remember trichotomy, which says that if we look at first of T1, there how many choices? 3 choices. Let us see what happens if we go through these choices. That's 3 choices. It's given to us. So we know the first choice is this. Do you agree? And what do we know now?
Okay, yeah, true, yeah.
Now, the second choice is x, y dot first is less than x dot first. How very nice, guys. You see, it becomes, the moment you start
Otherwise-
thinking from axiom, the code becomes self-evident.
X second less than Y second.
X dot second less than Y dot second.
By the way, what is
If you do that,
the implied precondition here before this return? They're equal. Why? Trichotomy. This wonderful trichotomy. So, yes.
So if X second and Y second are equal, we're going to return false for this.
Yes,
is
and
false.
so should
Should
we. Because then they are equal, and if they're equal, it's, I mean, you
less
know,
than is
this is strict. It's strict total ordering.
But if you're using this to reorder a collection, we're going to destroy stability, right?
No, I'll not destroy stability. How would I destroy stability? All of our algorithms, could we look at our min or max to see that we're not going to destroy stability?
you remember Bill.
Yeah.
It's actually, but this is a very important point which you just made, even when the conclusion was not correct. That is, you have to assure that whatever we got would work with min and did not destroy stability. It would not destroy stability.
I mean, in
Because
particular,
without
min assumes that if they are equal, less than would give it false. Otherwise, min is going to break.
So we have to, I mean, this is one of the things. Things have to be connected. And it's good to remember axioms because they actually do allow us to write code. I would even put in comments in front of it, assert x equal x dot first equal. Now we know, yes?
Why is it okay to arbitrarily decide that the first element is more important than the second element?
Yes, but let's go deeper than that. So why do we define lexicographical ordering this way? Yes. This is what, let us think about how we want to deal with things. Sort of this relates to our, for example, idea of ascending ordering as the default ordering. We somehow assume, again, I know you're going to jump on me, assume that going from left to right is more natural.
No, but there's nothing about
Obviously,
left and right.
going-
This is
no,
first
no,
and
no,
second.
I know. And so does he. Yes.
But do you
that's
count from 10 to 1? I don't think so.
right. Yes. No. Yes, and that's, yes. So in any case, you want your iteration and your ordering to coincide. So that when you go from this to next, it's going to be non-descending. This is sort of what we assume. This is what lexicographical ordering gives that. Of course, that also will be very helpful when we try to order sequences. Because again, the choice, do you go from the back, do you go from the front, what is, right?
So we've had this discussion before, but we also need to define greater than. So can you tell me how to do it?
Because obviously clever people say that they might want to have a different semantics.
Y is less than x, yes. And we need to define less than and equal to, and with a space here maybe. Not y is greater than x. Yeah.
I much prefer, when I write code, to write it in terms of only one glyph. That is, I assume that less than is given. It's very easy to rewrite. There is a principle which sort of
That's a principle that makes it more obvious that's wrong.
Yeah, but we could easily make it right by flipping y and x.
Okay, I'm confused.
We say that
X
this
is not equal to y
is x there, yes.
if it's not true that y is. Yeah, okay.
Yes, yes.
We have one more to go, and since I can't think, someone has to tell me.
It's not x less than y. I mean, these are the only choices, guys. If there are 4 choices, write them all, you will get them all.
You write them once and you can use them forever.
Right?
Until the compiler learns it, and then
Yes.
you may not
sort
revive
of
them.
Again, and maybe your grandchildren will live in the world where you can define one and the rest will be automatically generated.
But what if I want greater than and equal to mean implication or something?
You should go and find another job, in my opinion, or join the committee.
Okay, so we have ordering. Are we done with pair? What else do we need to do with pair? Do we need an iterator? It's a container.
Could we have an iterator?
Could we have an iterator?
Could we?
If you dereference the iterator, what type do you get? That is a good question. I mean, it is reasonable to want to iterate over everything in a pair. You might, I mean, for instance, we just did it, right? We had our equality, which was basically saying the first has to be equal and the second has to be equal. It would be nice to be able to write that, but I don't know of a way to do it.
I mean, there's a bunch of things like this. It seems like the equality, you might want to say, I only want to define equality when T1 and T2 are regular. I only want to define an iterator when T1 and T2 are equal. And provide those implementations, but have the language now.
There are some metaprogramming tricks that we used. Yes, but
is it
what else?
Possible? I'm curious. Is it?
I was simply going to suggest that there's nothing special about pair. You can just implement a tuple.
You can adjust tuple, yes. And in fact, tuple does actually face this problem because tuple is a variable. It can be, you know, any number of things, and there, to implement equality, you will need to use some metaprogramming tricks. they're not that hard once you start getting, thinking like that.
You act-
But they're not natural. They are not natural.
Technically, they're just variadic template tricks instead of meta programming tricks. I mean, unless you, depends on whether you consider variadic templates meta programming or not.
Agreed. Regardless, going back to the iterator question, it is, it would be nice to be able to write code like that, but there is no straightforward way to do that at the moment. So we can't really have an iterator here. So I guess.
By the way, one thing which I would recommend for all of you is to try to think, again, you might think, how do you do it in C++? But don't go this direction. Or how do you do it in Java? We'll use reflection. Try to think what's a natural thing. What do you really want to say? And if you start thinking like that, maybe your train of thought will go like so. You'll say, what is a record type, a struct? You say, well, it's a collection of slots of different types. And then you would say, well, wouldn't it be wonderful if you could get, in whatever language of choice you have to the record, to go to the third slot by saying record.3. Actually, record.2 would be the right thing. We should index from 0, obviously. But then you would say, and how do you get a type? And of course, in a properly designed language, there will be a trivial way of getting the type of the third element of a record, because the compiler clearly has it. It's not that it's some secret thing. So you would say record type 3 or whatever. It's a very, very simple thing. And then you will start thinking about what are these things, and you will discover that they're actually type functions. So if you take a type, record type, and it has multiple type functions which return you types of its fields. And it also has a type attribute, which is a number of fields. Remember, type attribute, it's something which sort of like a number which type has, like the canonical example of type attribute.
Size of, for
Size
example.
of. Right? So if we ever, again, before we go and design a language, whatever the language is, Rust or C++ or something, we try to think, what is that which is going on? We would have a chance to do a reasonably sensible job. Sadly enough, most of us start with saying, oh, we need to put object-oriented facility into C, or templates, or variadic templates. We, instead of figuring out what things are, we try to figure out what are language mechanisms. And then everybody discusses language mechanisms. Say, oh, object-orientedness is better than generics, or generics are better than object-orientedness. First, we have to figure out what is, again, there is a thing called struct. We have to analyze it carefully. We have to stop and think. It's actually quite simple. So, and then you could evaluate whether different solutions that languages propose coincide with what it's, again, sort of, when you think about total ordering, don't think about programming languages. Think about mathematics. There might be even problems with total ordering, but they would be mathematical, not programming language induced. So this is, And now I have a good news for you. The good news is that at least for a while you will see me no more, and there will be a better teacher. Param will be teaching next few lectures without me being present, so nobody will be able to interrupt except Ahmed. You would be able to get through some of the code successfully. What I do recommend to both you and Param if you get into things, and sometimes there might be these issues where you would say whatever. When you have a whatever, write it down and let's discuss it when I come back. Sort of, because maybe whatever, sort of, if there appears to be, you could do this or that, and there is no difference. Write it down on a piece of paper, and then we have some interesting questions to discuss when I come back. Right? So I'm not saying I'll know the answers, but this would be interesting questions. So, okay? Because the next thing we need to do is array K.
Yes.
And, I think that starting it now